a function is a special kind of relation where every element in x there exactly corresponds one element in y. In short, a function is an x equals 1y. Again, a function is an x equals 1y. Come on, function is an x equals 1y. Come on, function is an x. That's why the really common way to represent a function is this. F is the function, x is the domain, and y is the range. So it is read as a function of x equals y, or f of x equals y for short. If there are more than one functions, you can use g, letter G, or h for distinction. Remember, all functions are relations, but not all relations are functions. Number 3, relations can be represented by using table of values. It could be in a horizontal or vertical format. Using the same example, how can we represent them using table? Again, we group all the domain and range and present them like this, by rows or by columns. By just looking at the table of values, how will you know that a given table is a function or just a relation? Let's try this. Number 4, relations can be represented by using a rule or correspondence. Remember that the range depends on the domain, or y depends on x. Given this table of values, what have you noticed about the range in connection to the domain? Compare the y values from the x values and make a statement out of it. Whatever underlying principle or statement that you make that satisfies the table becomes a rule or correspondence. Did you figure it out? So we can say, each value of y is obtained by squaring the value of x, meaning all the y values are perfect squares. Number 5, relations can be represented by using equations. Because we have now the rule, we can express this into an equation. Going back to our rule, how can we express this as an equation? So, the rule is, each value of y is obtained by squaring the value of x. So, it can be translated to y equals x squared. That is our equation. Now, guys, we will do the reverse. What if the given is an equation? How can you construct a table of values? Example, we have y equals 3x minus 4. Because y values depends on x values, just choose any integers for your domain. Let's try x equals 0, 1, 2, 3, and 4. Then substitute x equals 0 to your equation, perform the operations, then you'll have your y value. Simple. Continue substituting x equals 1, 2, 3, and 4 to your equation to get all your y values. Now your table is complete. The process of substituting your given domain, then performing the operations to get your range is called evaluation.
Imagine we have a machine. The purpose of the machine is to take shapes and turn them into circles. At the top of the machine, there's a slot to place the shapes. Shapes that go into the machine are called input. At the bottom of the machine, there's a chute where the circles come out. The circles that come out are called output. Let's test the machine. Our input is a red triangle. We put the triangle in the slot, run the machine, and our output is a red circle. Let's do it again. This time, the input is a blue square. We put the square in the slot, run the machine, and our output is a blue circle. This machine accepts any shape as input. It runs and outputs a circle of the same color. Now let's switch our machine. Instead of taking shapes and turning them into circles, it'll take numbers and multiply them by 3. This time, our input is 12. We put 12 in the machine, let it run, and the output is 36, because 12 times 3 is 36. Let's add another machine. Now we have 2, one that multiplies its input by 3, and another that divides its input by 4. Notice how they're stacked together. The output from the multiply by 3 machine will fall right into the divide by 4 machine. Let's test them out. Our input is 4. We'll put that into the first machine. The machine runs, and the output is 12, because 4 times 3 is 12. Now the 12 falls into the next machine. That machine runs, and the output is 3, because 12 divided by 4 is 3. Since we know they both work, we can connect these machines together. This forms a bigger two-step machine. The new machine takes a number as an input, multiplies it by 3, divides that by 4, and spits out the answer as output. Since the machines are connected, we won't be able to see the output until both steps are complete. Let's try it using 4 as an input again. We put 4 into the machine, and now it passes from the first step right into the second step. Just like last time, the output is 3. Now that you've seen how two-step machines work, you can start thinking like a mathematician and computer scientist to use them to solve complicated problems.
Try to evaluate this. F of 2 equals x squared minus 2x plus 2. And number 6, relations can be represented by using graphs. Because relations and functions are just a set of ordered pairs, we can plot the coordinate of each point x, y on the Cartesian coordinate plane. Going back to our example, plot this on the Cartesian plane and describe its graph. Now here's our graph using the coordinate of each point. And if we connect the dots, it forms a straight line. So is this a linear relation or linear function? Yes, it's a linear function because it's a one-to-one relationship. How about this one? Construct your table of values and graph it. Just use perfect square integers as your chosen domain to easily solve for your range. Can we consider this a function or not? Wait, just given a graph, how will you know if it is a graph of a function or not? Here are some examples. Which of these graphs are functions? We can easily identify a graph of a function by using a vertical line test. It's like a vertical line scanner that moves from left to right. If the vertical line touches only one point as it moves along the graph, then that graph is a function. If the vertical line touches 2 points or more, then it's not. That's all for now, guys. Thank you for participating in our lesson. I hope you learned something today about functions and relations and the ways to represent them. Let me check before I end. Is one-to-one relation a function? Yes, it is. How about many-to-one? Yes, it is a function. Is one-to-many a function? No, it's not. The love of Jesus is not a function. It's more than a relation. He offers His life for all. And we call that agape. Stay safe, stay home, and stay productive. Jesus loves all of us. Bye-bye!
The input is the set of X, the output is the set of Y. And when you do the vertical line test, you always better know the reason why. With tables and graphs, diagrams, or equations like f of x. The set of inputs is the domain, the set of outputs is the range. When no x repeats, you'll have a function. The set of inputs is the domain, the set of outputs is the range. When no x repeats, you'll have a function. A function is a type of relation, but a relation is not always a function. An input may have more than one output, an output may have more than one input. When every x has exactly one y, we give that a special name.